Today we're going to cover 5.2 important theorems based on the parallel postulate. Our objective is to define and use the angle bisector. The angle sum in a triangle theorem. We've already been using this. It says the sum of the angles in a measure of a triangle is 180. So the three angles of a triangle are going to add up to 180. So we're given a triangle ABC. We've got to prove that it adds to 180. To do this, we're going to draw a line L through B parallel to AC and use properties of parallel lines. So you can refer to the pictures when we're doing the proof. We know B is parallel to AC. I'll go ahead and mark that in there. So B is parallel to AC. Alright. So, first step. How do I know that angle 1 is congruent to angle A? 1 and A are congruent. How do I know that? Yes, Eli. Yes, alternate interior angles. How do I know that 3 is congruent to C? How would I know that? Sam. Right. That's alternate interior angles too. Alright. Step 3. Angle 1, angle 2, and angle 3 equals 180. How do I know that? One, 2, and 3 would equal 180. How do I know that? What is the angle made by 1, 2, and 3? What do we call that? Yeah. Well, no, two angles are supplementary. You're on the right track, though. Yeah. Yeah, it's a straight angle, right? A straight angle is measured up to 180. So those three angles make a straight angle. So a straight angle measures 180 degrees. A plus 2 plus C equals 180. How do I know that? What did I do? It comes from the previous 3 steps. A plus 2 plus C equals 180. It is, yes, it's substitution because we took replaced angle 1 with A in the step 3 and 3 with C. So that's substitution. All right, and then step 5. Angle A plus angle B plus angle C equals 180. This is given in the picture. Right, so looking at the picture, how do I go from angle 2 to B? Really, if we're consistent with what I've been teaching you, we wouldn't call it just B, we'd call it ABC, angle ABC. Okay, that's substitution as well because it's the same. It's the same name for a different angle, so you're just substituting a different name in. So that would be substitution. Angle B for angle 2. All right, any questions? Okay. In the figure, AB is parallel to CD. We have to show A plus B equals 120. So this isn't a proof. We can just do it, sort of by making a few statements or observations. How can I show that A plus B equals 120? Eli.
Since the bottom line is a straight angle, you already have to measure AC line.
You what?
Equal ACB.
Yeah. Say again.
Find the measure of ACB because you have the straight angle to the angle measures.
Okay, we can find ACB, but that's not. Well, we need to find AB, A and B. Okay, the key is these lines are parallel. If this is parallel, what can I say? What other angle is angle 50? Bryant? Yeah, angle B by AIA, right? That'd be 50. So angle B equals 50 by AIA. And what does angle A equal? Christopher? Why? Yeah, CA. Angle A is 70 by CA. So, angle A plus angle B is equal to 50 plus 70, which is equal to 120. Alright? What we have just done there, that process, is what we've done, we've shown that the extra angle theorem. The extra angle theorem says an extra angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. Alright, so we've got A plus B, and we have BCD. BCD is the exterior angle. This is the exterior angle. It's equal to the sum of this angle plus this angle. Those two angles. We're going to prove it. Given triangle ABC, we have to prove angle BCD equals A plus B. So, what would I want to say for a statement that goes with the reason a straight angle measures 180? What could I say there? All right. Well, we'd say these two angles, BCA and BCD, are add to 180. So angle BCA plus angle BCD equals 180. Alright, angle A plus angle B plus angle BCA equals 180. How do I know that? Yeah, Madeline. It's not substitution. Yeah. Right. The triangle sum theorem, that the angles of a triangle add up to 180. Alright. Now, step 3. You have to come up with both the statement and the reason. What would be the next thing that would follow from this? What do you think we would follow? Angle BCA plus angle BCD is equal to what? Yeah. No. They do. They both equal 180, right? If they both equal 180, what do we know about them? They equal each other. So it'd be angle A plus angle B plus angle BCA. And that would be by what? Substitution. Good. That's substitution. So then subtraction. That's subtraction, property of equality. What would I have by subtraction, property of equality? What's in both equations that we could get rid of? Madeline. Yeah, we can get rid of the BCA. Subtract BCA from both sides. We'd have angle BCD is equal to angle A plus angle B. All right, any questions there? Okay. Everybody has it? Good. The angle side congruence theorem. We've used this too. This is just formally defining it. It says if you have an angle side correspondence, congruence correspondence in triangles, that the triangles are congruent. Now be careful not to mix up angle side with angle side angle. This would be, remember, you can only skip, as you go around the triangle, you can only skip one part. So if I started at this angle here and I went this, I need to go back. If I went this way, I'd have angle, skip a side, skip an angle, side, angle. I can't call it angle, side, angle because I skipped two parts. So if I go counterclockwise, then I've got angle, skip a side, angle, side, angle, angle, side. Right? Any questions? Okay, so that's angle side correspondence or congruence. Another one we have is hypotenuse angle. So we have hypotenuse leg and leg in right triangles. Now, in a right triangle, if I have the hypotenuse in one angle congruent to the hypotenuse in one angle of another, and it's a right triangle, then I can say the triangles are congruent by hypotenuse angle. How else could, in this picture, how else could I say the triangles are congruent besides hypotenuse angle? Yeah. Angle is not a congruence. Look at how it's marked. Yeah, Eli. Yeah, it's angle. Hypotenuse angle is angle side. Angle, side. All right. Bisector of an angle. In the figure, AC equals 10 inches. Find BC and DC. All right. So first of all, we have, before we go on to finding the angle, let's talk about the triangles. They share the hypotenuse, and they both have a 30-degree angle. So what could I say about the two triangles? Eli? Yeah, they're congruent by hypotenuse angle. So let's find BC, and if we not find BC, then CD corresponds to it. We'd know CD. What can I do? Okay, so AC equals 10. So since it's what kind of triangle is this? 30, 60, 90, right. This the remaining angle is going to be 60. So what can I do about the sides? What do I know? We can do our map, right? So 10 equals 2A. A equals what? A equals 5. Because If 10 is 2A, A equals 5. And A is the side across from the 30. So if A equals 5, if BC equals 5, then DC corresponds to it. DC equals 5. All right, any questions there? Okay, angle bisector theorem. A point is on the angle bisector of an angle if and only if it is equidistant from the sides of the angle. So P is on the bisector of angle A if and only if PB equals PC. We know that the distance is the shortest distance to the line. That would have to be a perpendicular. So if the distance from the side of the angle, this distance, this distance, come on. If this distance is the same as this distance, then I know P is on the angle bisector. Right? It's going to be equidistant to the sides of the angle. So P is on the bisector of A. We have to prove that P is equidistant from the sides of A. You can refer to the picture. AP is the angle bisector of angle BCA. How do I know that? AP is on the angle bisector of BCA. Michelle. It's given. By definition of angle bisector, angle BAP would be congruent to what angle? Braden. CAP, right. Angle CAP. That's the definition of angle bisector. Alright. PB is perpendicular to AB, and PC is perpendicular to AC. The distance from a point to a line is what? If we go from a point to a line, what's the shortest distance? What is that line? It's perpendicular. Distance from a point to a line is perpendicular. Alright, step 4. Angle B equals angle C equals 90. Right? They equal 90. How do I know that? Sam? Definition of perpendicular. What do I know by reflexive property? Eli? Yeah. AP is congruent to AP. That's reflexive property. So then we have triangle APB is congruent to triangle APC. How do I know that? How are the two triangles? Which shortcut is used to show the two triangles are congruent? Hopefully you've marked your figure as we've talked about it. Jake?
Angle, angle side.
That's angle, angle side, right. angle, angle, side. So then what would be my last statement? What would I end the proof with? That's right. Yeah, speak up. Yeah, another way we could say that is PB equals PC. Our corresponding parts. All right. Questions on the proof? Okay, I'm going to give you a break